it's exciting to look at the next few years, because we've achieved so much in this last 2 years. Really built an incredibly strong team, and we've got a fantastic plan. We've got market-leading technology, and I'm really looking forward to now advancing the maturity of that tech. It's very rapid, isn't it? It's a 5-year development program to our tipping point, really, the pilot plant in space, beaming meaningful power, being assembled as a substantial spacecraft, albeit in a low Earth orbit, but demonstrating all of the elements of space-based solar power and rapidly allowing us to then get to our first commercial product.
That's right.
A year later.
Yeah, very exciting times. You can really feel the momentum building. The next big step on our timeline is obviously getting the funding for the next stage.
Yeah.
We've had tremendous support from the investors to date, as well as great support from governments with grants. Great set of investors to work with, both from the energy space as well as venture capital, and we're looking to build on that in the next phase, as you know, Martin, into a really international set of corporates and venture capital and high net worth investors that are going to be so crucial, because we're trying to do this in a commercial setting, unlike a sort of fusion-style science project. One of the beauties of this technology is the ability to commercialize it on what is, relatively speaking, a very rapid timeline. 5 years may not always feel like that, but compared to our alternative technologies, it's really an astonishingly rapid roadmap.
Yeah, and it's such a transformative technology this is going to be. I think increasingly over the last couple of years, the difficulty of the energy transition has become more and more apparent. You know, how expensive intermittent renewables are for the whole energy system, and really how transformative space-based solar power is going to be. And that the narrative really seems to have changed. And I think space solar has played an important part in that narrative globally, really bringing it to the public forefront. And now it's a major investment class, particularly in the US. We've seen $100 million of private equity, private capital put into space-based solar power. Governments are backing it much more strongly.
I think others are starting to see what you and I have always seen, that this is a very incrementally stageable technology, that it's not a sort of spend billions and don't know where you're going to get to, but that it comes with really clear milestones that we can deliver first terrestrially on both of our assembly robotics as well as our power transmission capabilities, before we then test that in space, before we then scale it up, before we then transmit down to Earth, as well as proving our ability to build incredibly large structures in space, which is one of the really ambitious aspects of this program that I love. Yeah,
no, exactly. And I think, you know, we're a UK company with global aspirations, and it's got to be an international program ultimately. But I think really important that the UK government is a key partner for us in this, and a very proactive partner. And I think our early steps in demonstrating that in-space assembly, which unlocks so much for the space sector,
in the UK,
it's really exciting, and the UK in general, exactly. And so within 3 years, we're going to have an in-space assembly demonstration. Really, that's super exciting, and we've already demonstrated the core technology for that in our terrestrial Albatross demonstrator.
Yep. No, this is very clear in terms of where we need to take the roadmap from where we are today, and the technical team are incredibly excited and know their plan to deliver. And investors are really buying into the vision, because it is that clear starting with smaller milestones, building to the larger milestones only after we've done that de-risking, that allows us to build a virtuous circle here between private capital coming in, government support leading to more private capital, and ultimately to the goal of assembling massive power stations in orbit.
Yeah, and I think, and large thanks to you, we've really unlocked the difficulty for RF-based space-based solar power, which is the size of these early systems and therefore the capital requirements for them. And we've now got a really, really good plan for those early systems, which quickly scale into the very, very economic systems. And I think only yesterday there was an announcement in the UK of the cost, the auction for the strike price, the subsidy that the government is going to pay for offshore wind, which is about £127 for a 15-year contract. That's for mature offshore wind, which ain't going to get much more mature. And what's the prospect?
Well, it depends on the price of launch, as you know, Martin. But if the launch prices develop the way we hope they will, as low as $10, what's that, about eight pounds? And even if launch prices stay where they are, we're looking at around £20-25 for where we can do with today's launch prices.
Yeah, £25 a megawatt hour, which is, and for baseload, reliable, dispatchable, grid balancing power.
It's one of the superpowers this technology offers in the long term. One of the things that excites me most about the roadmap that we've developed is exactly that ability to start off with low capex systems, because it's always been one of the Achilles heels of radio frequency technology, and we've really cracked the code together on both the technology, the financing, and that first target market. That's going to let us get the best of both worlds of the amazing long-term economics that radio frequency offers, without suffering the downside of requiring those big systems.
It's really exciting looking ahead, because we're going to be absolutely transformative, both as a business. It's going to grow into a $1 billion business in clean energy, and at the same time it's going to be absolutely transformative in the space sector, particularly building large structures in space. The two big bottlenecks for space have been launch, where you can only fit a satellite into a payload fairing in a single rocket because you can't assemble, and energy. We're very energy constrained. And what we're building is going to unlock large systems and abundant energy in space.
In some ways, that's what excites me the most, Martin, because it is much nearer term and in some ways much more tangible, the ability to build these vast structures in space. Although we need it for our own satellites, the applications are almost unlimited in terms of industrializing space. And the UK, as you know, is a leader in a number of fields where that will be incredibly useful to build larger, better, more flexible structures at lower costs. And we already start to have that capability from 2029 onwards with our pilot plant as Osprey Tower, as you know.
And we've got letters of interest from some really exciting companies building data centers in space, from communication companies who are looking to the next generation of much larger communication satellites, which are going to need to be assembled in space. Data centers are really interesting, because I think it's so clear that the cost of AI and data centers is asymptoting to the cost of energy.
That's right.
And then with grid connections taking a decade or more, putting them in space potentially has some real advantages.
That's right. And the one that excites me is actually orbital habitats and orbital science, where our ability to build long linear trusses will unlock all sorts of different gravity environments.
Yep.
What interests you in the longer run about what we're doing here, Martin?
Well, I think it's just the transformative solution that we bring to this incredible challenge for humanity, where our energy demands, even just in the next 25 years, are going to be 4x times what they are at the moment. And at the same time, we're trying to transition to low carbon energy. One of those would be a challenge on its own, but both is really only deliverable with the sort of technology that we're developing. And in fact, it's really difficult to see another technology that's going to be commercialized within a decade, which is definitely the case for space solar power, and then scaled up at tens of gigawatts a year. Even nuclear fission won't scale at anything like that. Fusion is many, many decades away, and if it ever does become commercial, there's no pathway to that. So what are you left with? It's really tricky. You need breakthroughs, and space-based solar power provides this really viable solution which can address humanity's huge energy needs. And I think the thing that excites me most is democratizing energy access for developing nations, because I think that's such a stabilizing factor as well as a really important kind of societal need for those peoples.
That's right, yeah. And the scalability is just, I love it, right? It's scalable not only in terms of the long-term potential market, where even in geostationary there's 100 times the energy needs of the Earth, and there's no shortage of space in space for us to build those satellites over time. But it's also scalable in an economic sense, where because of the way we're approaching this challenge, the more we do, the better the price becomes, because we're ramping up the economies on a modular basis in a way that not only helps the economics in the long term, but helps us be really responsive to changing energy needs.
Yes.
So if you want to add a few data centers worth of capacity in the 2030s, this is a unique technology. No other technology is going to be able to respond on the same timelines to uncertain energy needs in the future, which means, of course, that we don't need to overbuild the system to the same extent, and we benefit from the incredible material efficiency anyway, so that we can get the best of both worlds of cheap, unlimited energy with very limited environmental impact to it.
Yeah, 100%. Yeah, it's about 1,000% less critical minerals mining and refining for space-based solar power compared to wind, solar, batteries. I think that's going to increasingly become much more important than low carbon. So it's really exciting to look forward to the next 5 years working together on this. Where do you think we're going to be in 5 years' time as a business, size, scale, impact?
I really think we're going to be a major global energy technology company ready to start the listing process, because we will have commercialized all of the key technologies that will let us move from our pilot plant to actual commercial delivery of energy systems that are going to change the world. And that's on that type of timeline for a technology that can revolutionize energy as well as industrializing space. It's astonishing.
Yes. Yeah, it's so exciting.